back to my YouTube channel. In this video, I'll be discussing about the double angle identities. In my previous videos, I've shown you everything about the sum and difference identities. So, in this video, I'll be discussing about another part of the trig identities, which is double angle identities. However, before you watch any further, don't forget to hit the subscribe button so you won't miss any of my videos. And if you do enjoy this video, don't forget to hit the like button and share this with your friends. So, we know that the double angle identities consists of three different equations. The first one is going to be sine of 2a. The second one is cosine of 2a. And the third one is tangent of 2a. And they're called double angle identities because they involve the doubles of an angle. So then, what is sine of 2a equal to? Well, let's just recall ourselves about the sum and difference identities for sine. We know that sine of a plus b is going to be equal to sine of a times by cosine of b plus by cosine of a times by sine of b. So, how will this be used to find out sine of 2a, you ask? Well, we know that sine of 2a is equal to sine of a plus a. So then, what if we use our sine of a plus b, but we change the b into an a? If we change this b into an a, it will be sine of a plus a, which is sine of 2a. So then same thing in here, become cosine of a, and here becomes sine of a, because we changed the b into a. So then, sine of a times cosine of a plus cosine of a times sine of a. That's basically equal to 2 times sine of a cosine of a. Because these two are the same. And when they're added together, they're going to be 2 times. And there you have it. And then, for cosine of 2a, we can do the same thing. It's going to be cosine of a times cosine of b minus by sine of a times sine of b. This is going to be our cosine of a plus b. Cosine of a plus b. And then, for our cosine of a plus a, which is basically cosine of 2a, we change the b into an a. This b will be an a, this b will be an a, same thing in this one. Well, cosine of a times cosine of a. That's basically cosine squared of a, right? And then we put our negative. And then, sine of a times sine of a is going to be basically sine squared of a. And then, we know that cosine squared of a minus sine squared of a can be further simplified. How? Well, we can use the Pythagorean identity. Which are those? Well, we know that sine squared of a plus by cosine squared of a will be equal to 1. This is basically a Pythagorean theorem that has been expanded so that it can be used for sine and cosine. So then, what if we solve for cosine squared? So then, cosine squared of a is going to be 1 minus by sine squared of a. So, let's input our 1 minus sine squared of a into this equation. So then, it's going to be that cosine squared of a is going to be 1 minus sine squared of a. So 1 minus sine squared of a minus by sine squared of a. And then, we can further simplify this into 1 minus by 2 sine squared of a. And that's the second way to interpret our cosine of 2a. However, what if we solve for sine squared rather than cosine squared? Well, same thing. Then sine squared is going to be equal to 1 minus by cosine squared. And then we input it that cosine squared of a minus by sine squared of a. Well, we know that minus sine squared of a is going to be equal to 1 minus cosine squared of a. So then we're going to minus by, in brackets, 1 minus cosine squared of a. And then, we can distribute the negatives, so it's going to be equal to cosine squared of a minus by 1 plus by cosine squared of a. Why do we make it into plus? Because we distribute the negative, and negative times by this negative will be positive. And then this will be equal to 2 times cosine squared of a, because the cosine squared has 2 in it, and then minus by 1. That's the second way to interpret our cosine of 2a. And then, what about our tangent of 2a? Well, same thing. We can always remember that tangent of a plus b is going to be equal to tangent of a plus by tangent of b over 1 minus tangent of a times by tangent of b. And then, for tangent of a plus a, we can change the b into a. And then, tangent of a plus tangent of a. That's basically 2 times tangent of a over 1 minus by tangent of a times tangent of a. That's basically tangent squared of a. And there you have it. That's going to be our tangent of 2a. So, now that we have our equation for double angle identities, let's try to do some questions. The first question, let's try to find out sine of, let's say, 90. We can use this by using our normal 30, 45, 90 triangle, but we can also use our double angle identities. Because this is going to be basically sine of 45 times by 2. And then we know what sine of 45 is, so we can solve it using our equation. So it's going to be 2 times sine of 45 times by cosine of 45. And then, what is sine of 45? Well, we know that sine of 45 is going to be square root of 2 over 2. Cosine of 45 is also square root of 2 over 2. The 2 cancel out, so it's going to be square root of 2 times square root of 2. That's basically 2. So 2 divided by 2 is 1. And of course, you can use your 30, 60, 90 triangle, 45, 45, 90 triangle, or your 1 radius circle to solve it. Number 2. Let's say that we want to find cosine of 120. So, we know that it's equal to cosine of 60 times by 2. So we can solve it using our cosine of 2a equation. So this time, let's just use this one. Although, you can use 1 minus 2 sine squared of a or this one. And then, it's going to be equal to 2 times cosine squared of 60 minus by 1. So what's cosine squared of 60? Well, cosine of 60 is half. Half squared is 1/4. So it's going to be equal to 2 times 1/4 minus by 1. 2 times 1/4 is going to be 2/4 or 1/2. And minus by 1 would be negative half. And then for number 3, let's say that we want to find out tangent of, let's say, 60. Although you can find this directly, and maybe some of you memorized it, but let's try to use our double angle identities, just for practice. So it's going to be equal to tangent of 30 times by 2, and in here we can use our equation. So then, it's going to be equal to 2 times tangent of 30. So what's tangent of 30? Well, we know that tangent of 30 is equal to square root of 3 over 3. So it's going to be equal to 2 times square root of 3 over 3 divided by 1 minus tangent square root of 8. 1 minus square root of 3 over 3 squared. And then 2 times square root of 3 over 3 is going to be equal to 2 square root of 3 over 3. And then what is square root of 3 over 3 squared? Well, it's going to be equal to 3 over 9, just basically 1/3. And then 1 minus 1/3 is going to be 2/3. So divide by 2/3. The 2 and the 3 will cancel out, so it's going to be square root of 3. And there you go. That is going to be tangent of 60 using our double angle identities. So if you like this video, don't forget to hit like button and share this link to your friends. And if you do love math, don't forget to check my other videos. And in my next video, I'm going to be discussing about the half angle identities. Thank you for watching.